So this is very crucial and important. I will tell you this. Units never leave this class. We will always be using units. I always expect you to be able to defer, analyze, and work between units. This is why I start chemistry out with units and I drill it for so long. So, here's what we're going to be looking at after I fix my periodic table because my OCD is kicking in. These are the 4 ones I gave you on your entry slip, and I did these to you on purpose. These are the ones I'm going to look at you and say, 2 are tricks, 2 are not easy. The tricks for you is this first one and second one. Here's where the tricks are coming in at. Remember our 4 rules. Step 1, what is it? Write the number times 10, something another. We're trying to figure out what something another is. Step 2.
Find the difference between the prefixes.
Find the difference between the prefixes. Step 3.
If there's only if there is an exponent on the unit, then you multiply by that exponent.
If and only if there is an exponent on the unit, we will multiply by it. Step 4.
If and only if there is an exponent to the base of 10, then you add.
So if and only if there is a exponential value with the number, do we add that at the end. Those are our 4 rules. Let me introduce you to the rule breaker. I showed this to you on Friday. Kenzie, Eli, you guys had to leave a little early. This is what you missed. Super simple. Whenever I introduce this to you, I introduce to you a centimeter by a centimeter by a centimeter is equal to 1 cubic centimeter. In chemistry and in science, we have a unit for that. The cubic centimeter is something very special called the milliliter. So 1 milliliter. Here's the dead giveaway. Somebody wake me up this morning. Get me going. Get me excited. Remind me, and I'm going to give you a hint here. Kenzie and Eli wasn't here, so it ain't on them. They can't give it to them. Remind me how we know the trick.
There's not an exponent on the.
Yeah! Bingo! Let's go, Sydney! You look at the first unit. Centimeters cubed, you go, holy smoke, there's an exponent here, this is a hard one. Then we go here and you go, holy smokes! Where's the exponent? This is the most helpful thing Mr. Hall will give you. If the exponent vanishes, it's a trick. Forget your 4 steps. What do you do? Lay it on me.
Copy down what? Just copy down.
You copy and paste the number. Let's go. So what number I put here?
14.6.
14.6. There is no times 10. There's none of that. We copy and we paste. You can tell your English teacher you plagiarized in chemistry today. We copy and we paste it. Yeah. Be honest with me. How many of you I catch that trick? I get you.
What?
I get you.
Halfway.
Yes.
Halfway.
I had to change it so that's actually right.
Hey, look.
I didn't.
Look into my eyes. I'm going over here, so those of you that watch this video later, you can see my eyes.
Okay. We'll get closer.
I want you to look into my eyes. This is a trick. Mr. Hall will always hold on to in his back pocket. I always use it. Cubic centimeters will live in this classroom. You will see it multiple times. Do you understand? If you just said yes, thank you. You spoke to a computer.
Hi,
Here's the
Mason.
thing.
Miss you.
Here's the thing. When you look at this, it's a dead giveaway. I will use this trick throughout this class, and you best know it. Comprehend? Okay. How about this one, my man? Mr. Hall, look at you, Mr. Hall, tricky, chicky.
What?
What we do here?
You have to identify your
Right.
prefixes.
Times 10, something or another. Then what we do, Kenzie, you
You
said
have
it.
to identify the prefixes.
Identify
I got
prefixes.
ahead of myself.
You're all good. So here we go. We got to identify the prefixes. In order to do this, what we got to do first?
Find what is
Base.
common.
Find what is common. Find the base. You find the base, you'll be successful. You know find base, you know find prefixes. Simple English, yes? So you looky at it. Looky here, I have one M here. What I got on the next
You
one?
got another
Two.
one.
I have two M's.
What?
So what does that mean? One M is?
This is the base unit.
It's the base unit, the meter, yeah? The meter. So you look at this. That means nothing to me. That means nothing to me. It's not important. You tell it. You're not important. Mr. Hondo tricked me. Then you look. Difference in the prefixes. Is there a prefix here? No, how you know there's no prefix?
There's nothing.
There's nothing there.
Manage.
What is this called? The base unit. Which is the exponential value of what?
0.
Very good. Mr. Howard, very proud of you. You take a hold of the SAT and you whip it until it goes home crying to its mommy. Understand?
Yeah.
Thank you. Now, looky over here. I have another M. So that's the base unit, right?
No.
Well, that one was the base unit. What is this one?
No.
Prefix.
A prefix of what?
Meter.
Peter.
Meter is not a prefix. Meter is the base unit.
I thought you was asking what was attached. That is milli.
I'm so sorry. Milli. Here is milli. What exponential value for milli? So -3. What happens when you subtract a negative?
It turns out to add a positive.
It's like you adding into a positive. Y'all can go brag and say that Mr. Hall is killing it to Miss Cochran now. Hey, you tell her we do the math in the science department. We dabble in the mathematics. We get a +3, yeah? If you do not know how that happened, go down there and join my little daughter's daycare class today, and they will teach you addition. They knock it down to the park.
Too well. You know what I'm saying? Hooray!
Do what?
I don't believe they introduced integers until the 7th grade.
Hey, all jokes aside, they kill it down there. Like, they teach them stuff. That's why I love it.
You show a number?
No.
Yeah.
All right.
No.
Step 3. Do we worry about step 3?
No.
No, why no?
There's
No.
no reason to.
No.
No exponents on the unit. So who worries about it, right? See? All right, let's break it. Step 4. Step 4, I worry about. Yeah.
No.
Oh.
No, why?
No!
There's
No.
no exponents.
But no exponent. So it's literally just a. How you do on that one?
Good.
Mr. Hop trick you?
No.
No.
I don't get you.
You can't.
No.
I'm so proud of you. You know that me trick you. Eli, ask your question.
About the centimeter cube thing,
Yes, sir.
if I had like 1 decimeter cubed, would that also be 1 centimeter?
No, that's a decimeter. If you look on their centimeters, if you look down there, centi is 10 to the -2.
So what makes it to where it only works for centimeters and millimeters?
What you're going to deal with is decimeter. Now, I can be wrong, okay? And this one I don't have to memory because I always have centimeters to memory. And I'm going to explain to you in a long route reason how this works for me. is if you give me anything in meters, I can get it to centimeters, and then I can get it into milliliters. Decimeter, I want to say cubed is equal to a liter. Now, I can be wrong. I don't have that one to memory. Yes, it cubed will equal into a volume, but the unit is different. I don't have it to memory. The one I want you to keep to memory is the cubic centimeter. Does that make sense? Does that help you? Just make sure you have that to memory. That's literally the only thing you missed Friday when you guys
So
walked
you're
out.
not gonna throw anything, any other random things at us, like, we just gotta know that one? Because you're giving me major trust issues
Nope.
right now.
And I have another question. When you say memorize all these, do you mean memorize like the
You see my marks on there? I did from peta to femto.
Okay. Do you want us to memorize the name or just the symbol and the exponent?
Name, symbol, and exponent.
Okay.
Here's the big thing is I'm not even so caught. You'll get the name, but it's like here. I need you to realize that that's like, well, yeah, that C is for centi. It doesn't matter to me if you really know the name right now as much as you know that's -2. So let's go over here. We got to the 12.6 times 10 to the 14. Woo! Gigapascals equal how many gigapascals? Ladies and gentlemen, does it matter if you know what a pascal is for? No, it don't. Thank you. Thank you. It means nothing to us. Who cares about it? I tell you what we do. We follow the steps. Mr. Hall gave you the steps for a reason, see? We're going to follow the steps. Let's write the number down.
Hooray.
10 to some another. Find what's the same. PA. Pascals, not Pennsylvania. Pretty sure that's PA.
God.
Look at your exponents. Here's first exponent. Little p is pico. What is the exponential value for pico? -12. -12. I subtract from it. What is the exponential value for giga?
9.
9. That giga is familiar to you. Gigabytes. That's where, that's the giga. Okay? -12 minus 9. -21. We're killing the math today. All right, step 3. Do I have an exponential value on the unit?
No.
No, so I don't worry about it. Do I have an exponential value I start with?
Yeah.
So step 4 we do. We add 14. Which gives me,
-7.
Yay.
boom.
Yay.
Was that a hard one? Yeah.
Oh.
Don't feel hard to you? That's a good thing.
Yeah, I thought I was.
No, I mean,
Means you are learning.
Yeah, that is really hard.
I gotta do this.
Just remember, when you see Miss Endicott, you say, Mr. Hall gave us challenging problems today. It was hard. Tell the math department be proud. See, we do math in here.
You're on this side of the, you can take next school for a reason.
Hey, listen, I'll tell you right now, I will be rolling through these students who y'all be there all day. All right, here we go. Same thing. We'll write the number down. The something another. We got to figure out what the something another is. We got to find the difference in the exponential value of the prefixes. The D and the B on my base units. Do you know what dB stands for?
Oh, really?
Decibel.
It is a decibel.
You said decibel, not a decibel.
Decibel.
You said decibel.
It's a unit of sound. So, find the difference in the exponents. Nano is what? -9. Minus tera. What's tera? 12.
12.
Which equals?
Negative.
Oh, they smokes, man. Look at that. It's like the numbers backwards.
Oh my
So it's a
God.
problem. Yeah.
Wow, we.
That's
amazing.
crazy.
All right,
This is a
units. Got any exponents?
No.
Oh.
Forget about it.
Forget about it.
Yeah.
Forget it.
Go to 4. Step 4. got any one we start with?
Yeah.
What we do with it?
Plus.
We add that thing. Plus negative 16. So negative 21 plus negative 16 is
Negative 37.
negative 37. I so thought y'all would be like all together in unison and throw that right at me, but okay.
Sorry.
So I got half the classes like negative 37, the other half, how'd you punch that in so fast? Boom, problem done.
Can't wait for the calculators.
What's your question?
No comment.
Talk to me,
No
okay?
comment.
Hey, yo, my quiet people, people that are like, not
Oh my
saying
God.
anything to me. I hate to single you out, I'll single you out for a minute. If they talk to me, how you feeling?
I'll leave the room if you want.
No, you loud, you rambunctious, stop talking so they have a chance. Feel good?
I can do these, it just takes more than 2 minutes.
That's okay.
6:28.
Okay. So, I have good news. If I have good news and bad news, which one do you want first?
The bad news.
Bad news, we are behind.
What?
This is horrible.
Who
I know,
did
right?
this?
Who's doing
Who
this?
sabotaged us? It's probably my,
I'm gonna-
like, ECA's fault.
No, it's called staggered start.
Oh.
Yeah,
It's a
true.
great idea, guys. It's like having all code me in for these 3 instructional days. Which I ain't saying nothing to y'all that I ain't said to other people. Drives me nuts.
Jeez.
Let's have freshmen come in, give them a day to get acquainted, and then boom, I want my kids in the classroom to throw. All right, Mr. Hall got good
I'm
news.
sick, man.
Hey, wait, Mr. Hall got good news and bad news also. I got more good news and
The
bad
bad
news.
news
I love
What do you
good
want
news.
first?
The bad
The
news.
bad news.
Bad news first. Okay, your
No.
first quiz is this Friday.
What?
Okay.
No.
Thinking, oh,
So,
this is
good
great.
news?
We don't have to, we get to stay in full class period Friday, so this is great. This
Hey!
is amazing.
Hooray!
Good news? Good news?
Yeah,
Yeah.
yeah.
Okay. Your first quiz this Friday is the safety test.
Yay!
Now,
Hooray!
to those of you that have, you will receive from me in this class, and we did that because of where we're going today. So, my question to you this morning, what are the 3 subatomic particles and how do they affect the atom? Hopefully,
Pro,
you can give me the 3 subatomic particles.
what she said.
It's gotta be
Neutron,
monosaccharide,
electron.
Let me
disaccharide,
do it.
carbohydrate, Mr. Hall.
Yeah.
It actually is the proton, neutron, and
Don't
electron.
you dare say
What
that.
do you
Terrorist
What do you
man.
mean? That's-
You are talking and speaking of sugars.
Isn't that, yeah, that's chains of sugars, Mr. Hall.
Mr. All, I think you got a little crazy.
She was purely.
Oh, did you guys hear about the mouse infestation?
Well,
Yeah. That's crazy.
That was just
Claire.
me running around. They started calling me a
Interrupt my class or something, it's right in the face. Tell you, if it's a snake, it's bitter. Alright, 3 subatomic particles we look at.
Protein,
Let's not do it like that. Let's do it like that.
Protein.
proteins.
Stuck in the.
So I can write stuff
Protein.
up.
Proteins.
We have protons,
Electric.
we got the neutrons,
That's sweet.
and we got the electrons.
I'm a neutron type of guy.
Pretty
Yeah.
easy.
Yeah, I get those vibes from you.
Talk to me about them.
What?
So protons have positive electric charge.
Okay, so let's define the proton. Positively charged subatomic particle. Yeah?
Yeah.
What's where's the proton located?
In the center of the atom.
In the center of the atom.
In the nucleus.
It's called the nucleus, we'll call it. Located at the center of the atom.
The amount of protons in an atom will tell you the atomic number.
Great point.
Thank you.
So you look at the proton, number proton, which I should let's do it like this. Number of protons. P with a plus sign, that's the abbreviation of protons. So, you ever like did something just to figure, like just to see? Like, there's a
Absolutely.
sticky note here at the middle of my floor that's been here for over a week. So part of me is like, I keep stepping on it and I want to pull it up, but then the other part of me wants to know, how long is it taking them to sweep through here?
Well, if it's any consolation, my friend, there was a shrimp tail in the girls' bathroom and it's been there for a while.
Shrimp tail?
A shrimp tail.
Yummy.
Somebody got hungry.
Okay, so the number of protons is equal to the atomic number. The atomic number can be found where?
There.
Like periodic table, it's the top number.
Yeah.
On the periodic table. So I've given you a periodic table, and this is the same one I printed for you. So here in the center, they have like an example for you. Here in the center, they have like this example for you so that you can look at it. Here is the atomic number, 80. And it will tell you the number of protons in that element. So here's the cool thing. What happens if I change the number of protons?
The element entirely.
I change the element entirely.
Wow.
Now I'm going to say something. And when I say this, I'm not being mean. But I want to address it because there's like a large group in the room that is kind of just rolling these off answers. And if you do not know these answers, that is okay. Do not feel pressure. Do not feel bad.
For Roxy.
They heard a lot of this last year. At least I hope it's where they remember it from.
No.
I'm at
I'm
what?
self-taught.
I'm not gonna talk anymore.
No, I want you to talk.
No,
but
I completely.
I just want to make sure
don't know.
everybody is not feeling overwhelmed. Oh my God.
I don't get it.
How do they know all these answers? They
I
just
can
roll them
find
off.
like half of
Because we're
these.
cheating, all of us.
Okay.
It kind of helped that you had a chemistry teacher for biology, so whenever it came to what's the first lesson I'm going to teach in biology, chemistry. So the number of protons equals the atomic number. If you change the number of protons, what happens? We talked about this very briefly last year. Well, what takes place is if you change the number of protons, you change the element. Leave a spot here because there's 2 points to this. I don't think anybody will remember the second, but the first one, they seem to. So it changes the element. See? See? Again, I hit the post.
Ooh, it's in purple.
So, to show this to you, I want you to look on your periodic table, for example. This is where I wish I had like 2 cameras in the rooms and I could hit a button. I wouldn't have to like pick it up. So, take a look here at boron. What's the atomic number of boron? It's 5. But let's say I add a proton. What happens?
It becomes carbon.
It's now carbon. The people that are not from my honors biology class last year, this one's for you. What happens if I add a proton to carbon?
It's nitrogen.
It's nitrogen, yes, thank you, thank you. Okay? Does anybody know the second thing what takes place.
Yeah.
Kenzie Mouse, girl.
Girl. Stop being bald.
I'm not bald.
That's so tough.
Ouch. Shots fired. Number 2. Not only does it change the element, but it's also going to change the mass.
You know what Einstein said right before he died?
Aaron Atkins is bald.
No, he actually said, Kenzie Mouse is so stupid. And he died.
Nice sound
Actually, I'm
effect.
Albert Einstein, and I know for a fact I never said that.
Oh, really?
Yeah.
All right, anyway, number 1, change the element. Number 2, it changed
I have no
the
rebuttal.
mass. Now, I want you to take 2 minutes in your groups and talk about the neutron, because I just threw a lot about you about the proton. Have at this. Hey Siri, start timer for 2 minutes.
No change.
It's just as there, honestly.
I think he's
He just levels it out.
inside, I'm pretty sure.
He's like the meat. He's
proton.
like the meat on the
Kenzie.
He's just hanging out. The neutrons.
The proton's like the muscle.
What?
The neutrons in the
Neutrons
The electrons the ball.
Electrons.
I mean, the proton's the ball.
Electrons just go around the outside. They're hanging out.
charge there.
Chemistry.
We're just talking about protons and neutrons right now. That'd be.
We're talking about, they don't have to be, you just have to have a certain amount of neutrons to be stable. If you have too many, or too few, no one's stable.
I thought it had that. I thought it had
I think it's funny where
And I thought that it didn't care.
They're neutral,
Bismuth.
heaviest particles,
Something has changed. They changed the density
they change the isotope.
or something.
I think that's it.
That's what he said.
They're kind of
You
suck.
gotta have
I like it.
the right amount, because unbalanced, too much neutral.
And then what?
You ever seen
Leptons
bismuth?
explode, radiation
Bismuth?
everywhere.
No, bismuth. Yeah, and anybody who says bismuth is wrong. It's
Me in my
bismuth.
room.
It's in my room.
That's what I was leaning towards. Me after I
No.
Yes, there is.
after I.
Oh, I think that it's bismuth.
All right,
Those people have to be hot, you just gotta have strong teeth.
Fingernails and stuff probably
I train my
radioactive,
jaw
and
every
it's
day.
gonna take millions of years.
all right, hey, so I apologize to you all. Today may be a little different because Hannah is not feeling
Training
so
is wrong.
Hannah is with Dad today. So
First two.
we'll see how this goes. Might be talking to you about subatomic particles holding the baby. This will be fun.
Does Hannah know what a neutron is?
Absolutely.
You better.
First
It's gonna
word
be on the
was
quiz.
neutron. I was there.
So let's talk
Saccharide.
neutrons. Talk to me.
Neutral.
No charge.
No
Neutron.
positive or
They're the
negative
sweet
They're the
charge.
heaviest one.
Nothing.
Subatomic particle.
They changed the,
They change the isotope.
and
Don't have too much.
they're like,
Having too few or too many makes it
they
unstable.
stable.
Be careful.
Can I say something to y'all?
Like,
You have no idea, but you are proving so many of my points right now.
It also adds stability.
that we're smart,
So true.
and that's
That's
what
one
I
point.
said.
It's pretty important.
I'll be so strong.
It's the heaviest.
Neutron,
You need to stop being bald too.
Okay,
hatred,
this is ridiculous.
neutron,
I'm gonna beat you up after class.
Neutral charge.
Bloody nerd.
subatomic particle.
Fight like a little sissy.
Oh, really?
Yeah.
You wanna find out?
Yeah.
Just sure you have to step in, you gotta stop before it gets out of hand.
Hey,
Meet me after class, Kinsley.
hey, stop.
Sorry.
Notice how he looked.
Ridiculous, y'all acting. Look at the example you're setting for my
I'm
daughter.
sorry.
Notice how
I
he
wasn't
looked at you.
thinking this at all.
All right, so neutral charge subatomic particle found in the center of the atom. Okay? Neutral charge subatomic particle found in the center of the atom. So you guys keep throwing this statement out to me about mass. What about the mass? Hey, baby girl!
The nucleus is where all the mass is, so protons and neutrons are the mass.
But the neutrons are the heaviest.
All right, I love how you all said it, but I love what she said because she said a magical word. What was the last two words you said?
The protons plus the neutrons equal the atomic mass.
Exactly. Protons plus neutrons equals atomic mass. So the atomic mass is equal to the number of protons plus the number of neutrons. Let's go teach kids shooting. Like everybody, you best listen. I'm in
She's
charge
got-
here.
She's so.
Yeah, she is. So the atomic mass is equal to the number of protons plus the number of neutrons. This is all found in the center of the atom. This is where the charge is also seen, but most importantly, it's where the mass is coming from. So, here's my question to you. What are you looking at? Ow! Croc attack. What happens if I change the number of neutrons? The n to that 0 power, that's the symbol for neutron. Okay, I want you to take a second, I'll give you 20 seconds to write the question down. Then I want you to think about it. Then I want you to talk in your groups and see what we got. Hey Siri, start a timer for 20 seconds.
To the office.
Is this wrong?
Blew up. So basically,
What we're doing, is this still part one?
blow up.
This one all?
No,
Is this still,
this is the new section, I'm pretty
is
sure.
this a new section or is it same?
It means section 1.1.
Huh?
I don't do
We're
section.
not
This
there,
is-
we're
this
not.
is-
We're
I
not
just do
doing.
notes.
Yeah, let's do.
Hey, y'all grown up, okay?
But
But
We're doing
listen,
metric conversion.
there's two things you're gonna learn in here real fast with me. Number one, this all connects. Number two, once you learn it, don't forget it, because all is fair game.
Ain't that right?
Ain't that right?
That's right.
Tell
Hey, okay, I'm gonna give you 2 minutes in your groups. I want you to discuss this. What will happen if I change the number of neutrons? Hey, Mr. Hall class here. I'm looking for something greater than looking and think, it'll do this. Explain to me why it will do this. Got it?
Yes, sir.
All right, Kenzie, how long am I giving you?
2 minutes.
Well, maybe. I'm asking you to do.
Talk about it. Agree.
Both of them, 2 minutes, let's go.
You know that Arby's ad? It's like, all our food is
Change-
blowing up.
I
That's what I imagine
Things
whenever you add too much
shooting off.
neutrons.
I mean,
Stabilize in the
become unstable.
You change the number of
It's like-
neutrons.
because it doesn't have positive.
I'm gonna have to go to counseling.
You say you start at zero,
Unstable,
you add some,
and then you
No,
have
it makes it radioactive.
comes in,
what Kinsey
nice.
radioactive.
Yeah.
Radioactive.
A lot.
Okay, when you add
Is that, but he sees a purple
And it does this
camera
because
in his
it's
mind and I was
unstable,
appreciating
but
it.
because you change the number of neutrons.
but it doesn't change the element.
If you add 3 eggs instead of 2 eggs of brownie mix, it's gonna, the mixture's just not, when you salmonella.
And depending on how many you add, it runs, it's stable, or it
The
will
thing
go
there,
up.
that, like, every.
You have to understand, as soon as he said, yeah, you guys can discuss, he looked at him like, you know that Arby's ad? I was like.
I was one of those things that whenever I think of
You need to start.
Michelle, I have one question.
Ask what?
In an element, is there a set number of neutrons per like?
7 eggs. You need
Like,
Imagine,
Okay, so.
what?
imagine if you put 11 eggs in there.
So every element has a fixed number of
Salmonella.
neutrons.
And then you
And then you die.
and then you get salmonella everywhere. And you,
Oh, man.
and you inhale it.
So like
it's
this
in your
has,
water
this has to
stream.
say like
Yeah,
six,
and then it's in your
six
bloodstream
neutrons.
and you die.
every
You
time.
die
I don't know how much it actually.
You
is.
can't
Or
put,
is-
from salmonella.
you can't
About
put 11 eggs
5.81.
in a
You're not
2
gonna
egg
listen
cake
to the
mixture.
phony and the faker.
That would just make it the mixture
was wondering,
unstable.
The other third
then-
false vanity
And
thing.
then you just eat eggs.
You know what, I
That's
wanna
not how
see
this
one ball
works.
person.
This is not the game of life.
Actually, there's a cake made
Uh,
of.
we don't know.
Or something that's
It's an omelet.
What is?
See, I thought it was like that. I thought
It
it
is
was
a
like
strip
that
of
has to be
cascade.
exact same every time.
All right.
But if it was one open and one closed.
Let's pull it together. Now, what happens if I change the number of neutrons?
Stability
No more stable.
can become an isotope.
set number of neutrons.
It's going to lose stability.
It's just gonna go haywire.
I like the word, okay? Thank
Haywire?
you, yeah. Thanks for saying
We're
that.
going Dr. Oppenheimer, guys.
Here's the key here. It can lose stability.
Yes.
Hooray!
Doesn't mean it's going to, it just means that it can. The second one, you guys kind of hit around at it. Second thing we deal with, changes the mass.
That's what we said, so.
So, proof point 2. Good point. Got a perfect example right here. Say, hi, I'm the example. Here's Hannah. When you look at Hannah, she just waved at you. I don't know who's waving at her, but she waved. So you look at Hannah. Is Hannah a human?
Of course.
When you look at me, Mr. Hall, is I a human?
Is this a trick question that you're talking about?
What are you about to reveal?
Milliliters.
No, not that guy. We're both humans. What's the big key difference? Don't go like, okay, I get it, like I'm a boy, she's a girl, I get that whole thing, okay? But look at us. Now I know what you're thinking when I say this. What's the key difference between us?
Glasses.
She's
Small.
Mr. Hall.
Okay.
She's a little guy.
She little.
Dares interrupt this class.
These are bad.
Kill them on sight.
What's up?
End of this class, you will still have her,
I will.
printer, I can't, there's just one little piece of paper, Jimmy, I don't know if I can get to it,
Okay.
before I throw it. Can you start breaking?
Yeah.
I'm breaking. I'm looking at it.
I'll come look at it.
You just show me there's probably a little simple place I can pull, and I can figure it out.
Yeah, I'll come look at it.
Oh, you good? We'll look.
Sweet.
What happened? You must tell
Look
us.
at it.
Appreciate you.
You're welcome.
Stupendous.
There's a key difference here, and that, another lesson. Okay,
I'm not gonna send you to the office, you're not gonna get in trouble. Mr. Hall is fully aware of his life situations and life choices he has made. I've been working on my dad bod before I knew I was gonna be a dad,
I think
okay? What's the big difference between Hannah and me?
She's an itty bitty
she's
fella.
compact.
she is so small. She's so tiny.
No.
I
What?
am Wumbo. I big. I big. I. Do you think that's funny? So, when you look at it, we are both people, but we have different masses. This is the same thing for elements. This is where the change comes in. Here with the neutron. When you break it down and you look at these, you have a very special word. Somebody already said it. It's on my phone. I'm proud.
Isotope.
Yes. We have isotopes, which are atoms of the same element but different masses. Not just different mass. They're the same element, but the thing that changes with them is the mass. For this to take place with isotopes, what has to change?
What?
The amount of neutrons.
What did you say?
For this to take place, what has to change?
If you change the proton, you change the element, and electrons don't, you can change the mass to a little itty bitty. So the neutrons are the only thing that can change, increase or decrease, but change the mass.
That's what's happening here with isotopes. If I change the protons, I change the element.
Star.
But if I change the neutrons, I change the mass, but I still have the same element. In other words, I've ate a whole lot of Krispy Kremes. She hasn't discovered Krispy Kreme yet. Okay, you got it? I love how somebody said it this year in biology. They looked at me and said, "My gosh, Mr. Hall, you got a lot of neutrons."
Oh,
Yeah, all right? True statement.
the sophomores?
Yeah.
Figures.
I don't like those guys.
So,
Do you want my?
no, I'm gonna give y'all credit.
Hooray!
Today's gonna be a little different.
So lonely back here.
So with the isotopes, we are changing the neutron.
I want to Dale.
That was ready to get out. What did I do with my red marker? Okay. Shoved it in the other pocket.
My bones are my body hurt.
So what changes in terms of isotope? What are you excited about, huh? The amount of neutrons changes. When we look at changing the amount of neutrons, something can happen. Something No, not so fun. We can lose stability. Whenever we lose stability, you have something special taking place in forming. Perfect example of this, I have 3 isotopes. We have carbon 12, carbon 13, and carbon 14. When you look at that, they're all carbon. So how many protons does each one of them have?
The same.
6. Each one of them has the same amount. Each one, carbon 12, carbon 13, carbon 14, each one has 6 protons. So what I have up there, that 12, 13, and 14, that's the atomic mass. These atomic masses, you sleepy? I understand. They're sleepy too. 12, 13, and 14 is those atomic masses. The atomic masses are being changed by what? The neutrons. So how many neutrons does carbon 12 have? 6. How did we get 6? Exactly. So atomic mass equals number of protons plus the number of neutrons. If I want to find the number of neutrons, I got to subtract the number of protons from the atomic mass. I'll break this down simpler later. So 12 minus 6 is 6. How many neutrons for carbon 13? 7. How many neutrons for carbon 14? 8. But here's the special. Here's how I started to explain this in biology this year. You're picking a date for homecoming. Carbon 12, she pretty. It's all good. She's pretty. You take her out. You take her to DQ, get an ice cream. Yeah. Carbon 13, she cute too. You take her out. Well, boy, hey, how you doing? Carbon 14, the stuff. Carbon 14 is special. Do you know what makes carbon 14 special? She's used in something. The scientists are all about her. Scientists are always talking about her. They're like, man, take her out. Carbon 14 is used in carbon dating. Hence the joke of taking her out. When you look at carbon dating, that whole premise and idea is based off of some things. The big thing here with carbon dating, carbon 14, is the reason they use it is carbon 14 is something special. Carbon 14 is what we call, well, I still doing green. Hey, don't you erase that. Your mama taught you bad habits. Carbon 14 is radioactive. What's it mean if something's radioactive?
Breaking apart.
Unstable.
Unstable, breaks apart. So, radioactive means unstable, and breaks start releasing radiation. Hey. Yeah. This is what happens. Carbon-14 is radioactive, so it will break apart. And radioactive elements have something called a half-life, which means half of this sample is going to break apart in this amount of time. What they use carbon-14 for in carbon dating is all about finding the age of dead things. So let's say you come up and you find an old tree. That old tree, you want to know how old it is. How are you going to do it? You take a sample of it, you examine how much carbon-14 is left in it. Based off of how much carbon-14 is left within it, that can tell you how old the tree is. You all right?
She's about to make a speech.
You have something to say.
Speak to them. Say, once you learn it, don't forget it. All is fair game.
So true.
She's shy.
Such wise
Oh,
words.
your eyes are puffy again.
Oh.
Yeah, she ain't feeling the best. We think it's just her allergies and a bunch of drainage, but we want to be sure. Somebody gets to see Dr. Fernald today. Yeah. Oh. Questions? I threw a lot of information at you guys today, and I know some of you probably came in here and you're not familiar with it, and I don't want you being overwhelmed by it.
To carbon date, do they need like a base point or something? Like,
They have an idea of like based off of how much carbon would be in it. So it's kind of like if they found my remains 100 years after I had passed, then they know.
Protons, change the element, and neutrons fall stability.
All right, so protons, change protons, change the element, change protons, also change the mass. If we change the neutrons, change the mass. And we change the neutrons, it can bring instability.
radiation.
Can bring radioactivity. Now, what is the whole reason behind the radioactivity?
Because can't keep itself together and things start flying and it's other things and it probably hurts.
So it can't stay together. Since it can't stay together, it's so unstable, it naturally is just going to break apart. Whenever it does that, it releases off radiation. Is all radiation bad?
No.
No. Not all radiation is going to hurt you. Carbon-14 ain't going to hurt you. When you get into other things, absolutely, it's going to hurt you. Hey!
Hello. You can still sit there. You're good.
Just gotta work on y'all getting here on time.
I'm a few seconds late. I have to get my book.
For what?
Because I can't change it because I have to catch the bus later.
I took the wrong hallway because I thought I was going to sociology.
Can I
That's all it is.
slip?
Yes.
Would you make fun of me?
It's happened 2 times.
I got here and fell asleep.
Hey, Carlos. Listen, I'm not as bad as freshman Italy. That's for sure.
Okay, so we hit a lot about these. What changes in terms of isotopes?
Amount of neutrons, that's what's going to change. I know I'm throwing a lot of information at you. If I'm going too fast with this, please slow me down, because I got some of y'all in here that are super quiet and you would never say nothing in the world. You gotta talk to me, okay? Goes for you too. You got this? You taking notes? All right, last one. We never got to it yesterday. The electron. You are kidding me. So the electron negatively charged subatomic particle found at the outer parts of the atom. Would you bear?
No.
You okay? You want to walk with it? Nope, okay. She is not going down. For whatever reason, she's scared of y'all today. So, talk about the electron. What's the electron control? What does it do?
Just spins around outside the atom.
Spins around.
If you
Come on.
affect the charge of the atom.
So it can affect the charge. Yeah, I'm telling you, I went home and I'm bragging on y'all. I'm bragging on your group. Because, like, literally, I told Mary, I'm like, they literally were rolling these answers off for something I taught them a year ago. And they knew it.
Does it control electronegativity?
No. That's something different. So, the electron can affect the charge of the atom. How does it do this? You can answer.
If there's protons and electrons, it neutralizes it, but if there's more electrons or less electrons, it'll change it to negative or positive.
Perfect. Do you know what I love so much about that answer? It's not how I say it. I love that. Good are your words. So, can affect the charge of the atom. How it does this? I guess I can formulate a question first. How does the electron affect the charge? First, all atoms of elements off the periodic table are neutral. What do I mean by when I say neutral?
Not particularly positive or negative.
It's not positive, it's not negative, it has no charge to it.
No.
It has no charge. I think I would know better than you. It's so hot today. So all atoms, elements, I'll start off the periodic table, they have no charge. So if you look at a periodic table over there, so look at carbon for example. Carbon has how many protons? 6. Since it has 6 protons, how many electrons does it got? It's the same number.
So is it really?
Yeah.
What was the neutrons of?
It's 6. Neutrons are neutral. But remember it this way. Electrons are negative. Protons are positive. I have to have the same number of positives as negatives in order for it to be neutral. So when you break it down and you look at them like this, every element off the periodic table, as soon as we pull it straight from the periodic table, it is what we call neutral, no charge, same number of protons as electrons, and same number of electrons as protons. But do they stay like this? No. So number 2 thing, can build charge. I'm going to finish the thought up here. So, electrons have what charge to them? Now you have to keep that in mind that they're negative. Keep that aspect in mind. Don't go to where your mind automatically wants to take you. So it can build a charge. Let's say we add electrons. What's the charge of the electron? Negative. So you have to look at it in this sense. I'm adding negative charges. If I add negative charges to an atom, what charge do we get? Negative charge. What if we subtract electrons? You're going to get a positive charge made. This all comes based off of what I'm adding and what I'm subtracting these electrons. Okay? How many of you in this room are familiar with everything that we just covered? Have you heard it before? Please raise your hand. That's okay. All right? Put your hands down. I have a firm philosophy. It does not matter what you come to me with. I will teach you what you need to know. I threw a lot of information at you guys. Tons of information. Please, don't stress. If you have questions about it, ask. Is there any questions? Nobody has a question. Okay. So, covered the 3 subatomic particles. Now this is what I'm going to get into. I'm trying to pull up my isotopes. Oh, wait. I gotta get this one too.
question to you. Does the electron have a mass? I'm gonna give you like 15 seconds. Tell her I appreciate her. She's an angel. All right, now I'm gonna give you 20 seconds in your groups to talk and discuss it and see what you think. Does the electron have a mass?
Yeah.
Hey Siri, start a timer for 20 seconds.
So
So true.
so rude. Why?
So little mass.
I don't think it doesn't have.
Exactly. That's rude, you know.
It kinda didn't be like
It doesn't matter. Maybe it does.
All right, what y'all think? Does it have a mass?
Little to none.
Yes.
So it has mass.
It's just
Yeah.
ignored. It's ignored because it's so small. Doesn't make a difference.
See, this is what happens whenever you have a chemistry teacher for biology. You know these answers.
Wasn't this like
Does the
a
electron
section
have
last
mass?
year?
Yes. New question. Where does the mass of an atom come from? You're going to taught you a horrible habit with the rest of my board. Wow, wow, wow. Rah, rah, rah. Rah, rah, rah. Oh, God. You ain't a dentist yet. 20 seconds. Little groups. Talk about this. Where does mass of atom come from? Hey Siri, start a timer for 20 seconds.
Typically electrons. Nobody cares.
Stop being rude to the electron, okay? It's trying its best. I'm not an electron. I'm a positive guy. You know this.
Negatively charged.
They're just outside.
I constrain myself.
She remembers you.
Played. Too long.
All right, so come on now. Let on. Where does the mass of an atom come from?
Proton and neutron.
Protons and neutrons. Right? Well, I got a problem here. Does the electron have mass? Yes. But only the protons and the neutrons are what we're looking at to say that those are what brings mass.
Did he like die or something?
Why do we not include the electron in the mass of an atom?
Barely. It's just that.
Hold up a second. We got a booger.
Would that be the electron stuff?
Hannah. I didn't get it.
Guess what?
I said so.
I have no idea.
Oh, hey, I am going to give you a minute in your groups to discuss this. Why do you think we do not include the electron in the mass?
Is he doing better?
She's a little better. She's still rough.
He looks better.
Changes.
I'm not taking the disrespect of the electrons anymore. Not that I,
Thank you.
but I will represent them.
I give you a minute. 1 minute. Hey Siri, start timer for a minute. Hey, we yelling at us.
I literally am. You ain't missed much.
She said y'all.
We're splitting
We're splitting up today.
in one second.
Yeah.
She said we can work ahead. We can't. We can't work ahead.
We can't physically work ahead without lecture time.
And
We
yeah.
have to be lectured in
That-
order to work.
And also, most of the signs are not
locked.
open. Yeah, they're locked.
I'm so great and happy for you. You've been out of my class long enough. Especially you, mister. I've already missed a day. Sit down and get to the chemistry.
Yeah, but you guys didn't do anything on the so it really don't matter.
Yeah, I can be mean.
We discovered a new element. Stanneridium-2.
Two.
That wasn't fun.
They couldn't find the first one.
We lost it. It wasn't funny though.
No.
Covered me. It's not.
Oh, like,
Okay.
You know this. Chris Meyer.
She's adding more.
Mr. Hall,
Yes.
can you scoot over just a hair?
Absolutely not.
Thank
I wouldn't take the disrespect, Mr. Hall.
Okay. Why do we not include the electron into the mass of an atom?
Because it's so small. Look at
Look
that.
What do you mean it's so small that it's ignored?
Affect the number.
I mean, protons and neutrons are small.
It has.
They weigh like
it's
nothing.
Significantly smaller than protons.
You
Yeah.
compare it to like a water
It
drop
would
on
be
an
like,
elephant or
it
something.
would be like trying to get the weight of an elephant that has fleas on it and then
Yeah.
saying, wait, elephant, we gotta take the fleas off. It doesn't make much of a difference.
bag.
Just don't count
You put an elephant
Look
on
at
a
us
scale
go.
and put your
I am
pencil
like
on it.
so super proud of you. I have no
You
idea.
know, I remember.
Because you know what you're doing to me right now? You are proving me right in so many conversations.
Crying.
No. Y'all are proving me right in so many conversations that I have, it ain't even funny.
So,
Why is not?
So, yeah.
Yep. Good job, baby girl. So, why not? In comparison, the electron is so tiny. The electron
I think she
is
should.
1/1000th
Personally.
the size of a neutron and a proton. So the electron is so small compared to the proton and neutron. It takes 1,000 electrons to add up to give us the mass of one proton or one neutron. That's how small they are. So, yeah. You are the entertainment today. I want you to
Is
know.
your hearing okay, Mr. Hall?
Huh?
She's checking on your hearing. Is it okay?
She wants to see if I have an ear infection.
What was that one she had?
She's like, yeah, she has an ear infection and she has a head cold. But they went ahead and tested her for all the respiratory viruses too.
I had an ear infection in kindergarten. It hurts. So.
Girl, I had one in the first grade and I had to sit out for recess.
That's actually like tragic.
My vibe was destroyed.
You like my wife's addition to the board this morning, by the way?
Happy almost
Yeah.
Friday.
Yeah.
I thought that was you, Mr. Hall. You just ruined my day.
No.
I thought that was you too, but now that I look at it,
It makes
Looks like
sense
your
now.
handwriting
I
was
like the
wrong.
little dots.
Yeah,
Thanks.
I like dogs.
So, let's talk about it. A good analogy I draw to this is, let's say that you all decide that you want to bring it come homecoming this year.
Absolutely.
So you go and you're like, we're getting an elephant. Yeah, we're gonna get an elephant. With the elephant though, it's very important that we have to know the mass of it so we don't destroy the new field. It can only be a certain mass. So you ask Mr. Hall to help you out. I take the elephant, I put it on the scale. Elephant turns out being 10,000 kilograms. Got a number, suits, it's fine, starts coming off. I look and I go, whoa, this ain't accurate, guys. You all go, wow, what you mean, Mr. Hall? I said, this elephant has fleas. What? Yeah. So at this point, I look and I say, all right, we're gonna give it a flea bath. And by we, I mean you, and me and Hannah's gonna supervise. And by supervise, I mean we're gonna chill in our chairs, playing with toys and drinking lemonade. She's gonna play with the toys, I'm gonna drink the lemonade. So, we do this, you kill all the fleas off. You put the elephant back on the scale. What's the scale gonna show? It's gonna show the same mass. You're gonna get 10,000 kilograms again. Why?
because the fleas were essentially weightless compared to the elephant.
In comparison, that's the key. Does a flea have mass? Yeah. But with that flea having mass, does it even come close to comparing to an elephant? No, so the scale's not going to show it.
It's like, do you think Big Kitty was so big whenever he had fleas that it didn't matter? He was
Big
big.
Kitty's so big. Big Kitty got a gravitational pull going on, okay?
I found him, he got scared of the thunder today. And I found him in the shower this morning.
Wow.
I don't even know how he got in there because it's like one of those, the glass door. I don't know how he got in.
Can't open the door, you just opened it.
He was taking a shower. Why did you walk in on him?
Huh?
He was taking a shower.
Yeah, my bad.
Disrespectful.
That's hilarious. Okay. On your periodic tables, you see something. Okay. You'll see. I almost fell. It's okay. You see some information here. Don't touch it. Don't touch it. I'm trying to get this. It'll mess me up.
Can we buy some bismuth?
Please tell him
I'll-
it's business.
I really want bismuth.
Tell him it's business.
It's bismuth. Sorry, can you please be the camera guy?
Yeah, you got it.
Okay, here we go. So, what you look at on here, you look at the periodic table. One I gave you
I know
has
some.
this in the center to give you ideas of what it is. We've already talked about one of these numbers. Now I want to move in and transition and talking about the second number. Okay? First is the atomic number, right here in the middle. What's the atomic number? The number of the protons. Now down here, you see this one, it says average mass. This one's very special. I have a more specific name I like to call this. It's not just the average mass, it's the average atomic mass. It also goes by the average mass number. But there's something very important when it comes to it. You need to know how to calculate it and where it comes from. I need to calculate it.
I have one right there.
You all probably do.
I would-
Fancy
I
though.
would,
Yeah, it don't matter. You don't have to use a fancy one. I'm just saying you can. I'm taking this back.
Okay.
You steal from me? Ridiculous.
I didn't do it.
Eli.
Yeah, you did.
I'm being frank.
You watch your hand.
Mr. Hawk.
Mr. Hall.
No, y'all good. Go class.
How about you just don't go?
Yeah, we got
Don't
a
worry.
biology quiz today.
Literally,
Let's
who's
go.
gonna stop you?
You're so right, I should.
Mr. Charles.
You can't stop.
Is he, where's your
Where's your
professor at?
professor?
Okay,
What was it say?
what we're gonna look at
Come over here.
is
Yeah, professor, it's a woman.
how to calculate average atomic mass.
Spanish woman.
I thought you just called professors no matter what.
It's like
Later.
Spanish.
You're killing me.
You never got through the Spanish? No.
Oh.
She said professor.
Can't do that.
I had an A in Spanish. But you
Yeah,
know-
Dad's got you. Okay, average atomic mass. When you look at average atomic mass, you want a different definition for this. Hello. So the average atomic mass is what we define as the average, gosh, mass of an element. Yeah, baby girl. What is it? You feeling better? The average mass of an element taking into calculation.
She really likes this topic.
Yes, she does. She is my child. Taking into calculation the isotopes of an element and their percent abundance. So when you look at this, that number up there off the periodic table is taking all the isotopes that exist in the account and their percent abundance. So the isotope, you know what it is.
What is the percent of abundance?
Which is taking me through the second one. I'm about to define for you what the goal of my Montana is.
Wow.
Hey, go yay, Tanner! Yay! There you go. She gave you a clap.
Thank you.
Oh, I'm sorry. You erased this, Hannah? Wow, Mom's gonna be so sad. It's a good thing you erased it, though. Right, everybody?
Absolutely.
So, percent abundance. Come this way. All right, not textbook definition here, Mr. Hall definition. Definition that you understand, that's what I'm after. Percent abundance is a percentage for an isotope. Hold on, I'll get you. For an isotope, it's a percentage for an isotope of an element that shows what percentage of that element, what percentage of that element is of that isotope. In other words, it's saying out of 100% of carbon, saying that 99% of it is carbon 12. 1% of it is carbon 13, and 0.00001% of it is carbon 14. It takes into account all of that element that exists and gives you a percentage for what gives you a percentage of that isotope for that element. Oh boy. Y'all see me the rest of the day. I'm going to cover the cheese puffs now. It's good. As long as it's good. Dad's going to be wearing snot and cheese puffs now. So, how are we going to calculate this? Okay. Thank God you stand up today. I want to show it to you. It is very simple and it is easy, but you need to make sure you have this into account. There's two things that have to be gave to you. I have to give these to you. I don't want the puff. First thing, I have to give you isotopes. Second thing, I have to give you the percent abundance. I found that copy on here somewhere. Okay. Simplistic way of doing this. Here's how I will do it. So I'll give you a copper 63, copper 65, right? I don't keep these numbers to memory, is why I'm having to look on them. Copper 63, copper 65. If you look at copper, copper's atomic number is 29. So those numbers up there are the what? Atomic mass.
Atomic mass.
Oh, thank you, thank you.
You're welcome.
Atomic mass. So the 63 and 65 is atomic mass, and that's how much these isotopes, that's the mass of those isotopes. Now the percent abundance is where things can get a little tricky for people. So 69.17% of copper is copper 63. Then you have 30.83% is copper 65. Now, to do this, it's very simple. You take
I need all freshmen that are in Melissa Cochran's homeroom, which is 9-4, to report to the DLC to pick up your Chromebook. All freshmen who are in Miss Cochran's homeroom, 9-4, report to the DLC to get your Chromebook, please.
I'm going to show it to you because we're short on time. Then I'll define it tomorrow. How's that sound?
Sure.
Better? All right. You will divide these by 100, or as Miss Cole liked to say, scoop the decimal 2 places to the left. 0.6917, 0.3083. Then we'll multiply those numbers by the atomic mass. So we'll take 63 times that decimal, 0.6917, and we're going to add all these together. So 65 times 0.3083. Punch that in a calculator. Don't do it. Don't do it. Don't do it. I'm about to give you another one. And we get 63.6166, and those are grams per mole. That is how it's done. Tomorrow, I will show you and define to you how it's done more. I'll even have a practice sheet. Yay! Thank you. Please have a great, wonderful rest of your day. Want to like give me a heads up and make sure I'm home first, especially if my wife
They'll wait.
and child is home without me, because then she's gonna like
I'll bring my little sister
be
over.
freaked out.
Don't worry.
Yeah, I'm gonna come play with
I'll
some.
bring all 7 of them.
So,
Why did they send me an email like this?
how?
They sent the email like one letter per line. I went to reset my password on Remind, and they sent the email one letter per line. Mr. Hall, I'm trying to communicate with you when I'm lost.
You're communicating with everybody else and your attention is everywhere else but on my class.
His undiagnosed ADHD kind of was like,
Stone this man.
Alright, so that you get an understanding of how to do these. I'm going to work through. That girl still hasn't brought me my pliers back. Y'all know who that
You want
was?
us to teach her a lesson?
Okay, good. So remember, you're going to have the isotope and the percent abundance. But here's the fun part, is where life becomes interesting. And I'll go ahead and show you and tell you where this can become more difficult at. I may not give you an actual element. I may tell you it's some unknown element. Which makes life fun. So I'm going to give you some unknown element, X. And let's go X30,
CU.
X32, X38. So 3 isotopes. And then some percent abundances here. Oh. Don't mess up with the isotopes. Don't touch those. There. You can touch that. Oh.
This is new, don't worry.
So you got these 3 isotopes. Here's the first thing you got to get. Anytime I want to ask you to calculate the average atomic mass of something, I have to give you the isotopes and the percent abundance. I have to. I can't give you one and expect you to solve it. You have to have them both. No, not the X. So, to do this, I want to give you the steps, and these steps are the steps you will always follow.
That's what I'm saying, Mr. Hall.
it's in purple.
I think that's pearl. That's pearl.
Gosh, girl.
Purple.
Since Mason's all about the steps, I'm going to add a step here.
Uh-oh.
Okay, step 1 is pretty important.
Oh, no.
tear it up, your percent abundance.
Yeah, I'm used to it.
You should give her a marker and let her go ham.
Yeah, give her a marker and let her chew on it and get it all over her face so that I can see her mother later and be like, why does my child have blue marker all over her face? It's like, I let Dale hold her for like 5 minutes.
I would absolutely.
Next thing I know, it's like he decided face paint.
I'd be great with kids.
All right, clearly, step one is a joke to solving
What?
the average atomic mass. But step one is a key component, Rose, thank you, on success in your chemistry class.
He was here in spirit.
I was
You take that in the trash and throw it in the trash.
Take his spirit and throw it
I
into
was
the trash?
still here, just not present.
That's,
That's even worse.
he was present but not here, I think he meant.
That's what I'm talking about.
So, step one, really.
Why are there 2 step ones?
Oh, good going.
You have to do them both at the same time.
That's like step 2 because 1 + 1 is 2.
I have to come to class and move the decimal.
Move the decimal 2 places to the left to get the decimal of percent abundance. Yeah, it's pretty important. If you do not do this, there's massive trouble. We're already hurt before we ever get started. So this is step one. So we'll remove the decimal. 1, 2. I need a 0 there. And that does away with the percent sign. You are killing me. Hopefully you got those wrote down because she is messing my markers all the way up. Can I have like 5 seconds?
Here. Hannah, I'll pay you $20. Like, give me the answers on the test.
Move all of them 2 places. Does away with the percent sign. So that you guys can see it better. So dot 0, 7, 4, dot 8, 3, 6, dot 0, 9. Those are our new numbers. Those are the decimals of the percent abundance that we're looking at. Before I do anything, there's something I love to teach people. I love to teach them to do something called checks. What would make sense here? What number do you think will be closest to? So I have 30, 32, and 38. We'll look at the percent abundance. Around 7% is 30, 83% is 32, around 9% is 38. What number do you think will be the closest to? Which number has the big lump sum of the percentage?
The middle.
So I expect to be closer to 32. Now it could be just a smidge off because this is 38 and it's 9% of it. But I'm going to expect to be close to 32. That's just thinking ahead so that I can check myself. So step 2, you will multiply each atomic mass of the isotope by,
That's what I'm saying.
multiply each atomic mass of the isotope by the decimal
I hear the flash machine install.
of the percent abundance. Third, add those numbers together. Oops, you found a book. It does not matter how many isotopes there are, you're just always going to multiply them by that. If there are 3, then there'll be 3 sets that you'll add together. If there's 12 isotopes, there'll be 12 sets that you add together. So in other words, this is what I'm saying. Parentheses, take the atomic mass of the isotope. The mass here is 30. Now I'm going to give you a unit here that's very important. Do not worry and do not fear. This unit becomes very prevalent to you come next week. Don't do it. Basic shot.
Throw it, throw it.
It's grams per mole. Stop telling my child toy.
Where'd you get the 30 from?
The topics.
Oh, okay.
That's atomic mass. Class. Multiply that by the decimal of the percent abundance. Remember, the decimal of the percent abundance. So 0.074. We're going to add to that the next one. Atomic mass is 32 grams per mole.
Bless you.
Times the decimal percent abundance. 0.836. Add with that isotopes 38 grams per mole. Multiply by the decimal percent abundance, 0.09. And we're going to get an answer. Here's what I like to do. I like to punch it on the calculator altogether. I had a calculator.
Can we get calculators?
She is watching y'all like a hog. What are y'all doing?
You don't work.
No.
Oh man,
She cannot see you.
I love my wife. She let my child play with my calculator. Now there's cheese puffs all over it.
Really teaching them young, huh?
That's what I'm saying.
So sure.
Straight up.
Listen.
Punch this whole thing in the calculator. What number should we be close to again?
32.
30.
So that should be where we're close to. I get
After
32.392. That's grams per mole. That is